Next, we'll move into the final major brain area, and that is the cerebellum. So the cerebellum sits under the occipital lobe of the cerebrum. It is the second largest part of the brain. It is also divided into two hemispheres. It coordinates the fine movement of skeletal muscles and stores memory of things that have a pattern of movement, such as playing piano or riding a bicycle. It also helps to perfect the timing and the appropriate patterns of skeletal muscle contraction, processes input from the cerebral motor cortex, which drives our movement, brainstem nuclei, and sensory receptors. So it helps us to have a smooth and coordinated movement and to do subconscious activities. I mean, think about when you get in to drive your car. Do you have to think about every step along the way in order to start your car, put on your seatbelt, put the car in gear, press the accelerator? No. The cerebellum helps to control that unconscious activity. A variety of drugs and alcohol can impair temporarily or even permanently the cerebellar function. So the classic sobriety tests that are performed if you get pulled over because the police suspect you of drinking assess the symptoms of impaired cerebellar function. So disturbance of gait. Can you walk a straight line? Well, if you've been drinking, you're impairing the function of the cerebellum, and you probably are not going to walk a straight line. There's also the loss of balance and posture. So when you attempt to stand on one foot, you usually are not going to do so very effectively if you're under the influence. And the inability to protect proprioceptive information. So if you close your eyes and they ask you to put your fingers on your nose, if you're under the influence of drugs or alcohol, well, you may very well not be able to find your own nose. Now, this is due to the reduced ability to sense that proprioceptive information and the uncoordination of the skeletal muscles required to do so. So it takes both the cerebellum and regions within the cerebrum to control and modify motor programming that produces somatic motor movement. Now, somatic motor movement, guys, that simply means movement of the body, so our voluntary muscles. So very complex subconscious motor patterns are controlled by neurons in the cerebellum, the cerebral nuclei, and the midbrain. Now, these are things that you do without thinking about it, such as I mentioned earlier, driving your car, riding a bicycle, the way your arms move and swing back and forth when you're walking, or things that startle you and produce a movement. Now, your complex voluntary somatic motor patterns are controlled by the cerebral cortex. So there are interactions with the midbrain, the pons, the cerebellum, cerebral nuclei, the motor association area, and the primary motor cortex. Now, you may not think about all of that being a part of every time you choose to move a body part, but it does require that very complex and very controlled interaction between numerous brain areas.